we're asked to prove that triangle ADC is congruent to triangle BEC. So this left triangle is congruent to this right triangle, and the figure is not drawn to scale. And we should never assume that it is. And then we have some givens here. So they tell us that segment AC is congruent to BC. So AC is congruent to BC. And they also tell us that CD is congruent to CE. So CD is congruent to CE. And I got to mark it twice because CD is not necessarily the right length as CA. In fact, they don't look anywhere close, so we can't assume it. But they tell us that CD is congruent to CE. So what else can we figure out about this little diagram here in order to be able to say this left triangle is congruent to the right? Well, the one thing we know is that this angle right over here, angle ACD, is congruent to angle BCE. So let's write that down. Angle ACD, and we don't have to write the angle symbol, and it's not easy to write the angle symbol anyway. It figures it out later that we're actually talking about an angle. Angle ACD is congruent to BCE, and we can say that because they're vertical angles. Vertical angles are equal. Fair enough, and there you go. It added the angle symbols for us. And now we can, I think, well, that's enough information to say that they are congruent. We can now say that triangle ADC is congruent to triangle BEC. Triangle BEC. And we know that because we have a side, an angle, and a side. A side, an angle, and a side. So by side, angle, side. Side, angle, side congruence. Sometimes it takes a little bit of time. It hangs up a little bit. Luckily for me, this time it did not do that. And so I think I am done. So let me check my answer here. Drum roll. And it worked.